Mr. Armstrong, I do realize that when you were on the moon, you had very little time for gazing upwards. But could you tell us something about what the sky actually looks like from the moon, the sun, the earth, the stars, if any, and so on?
The sky is a deep black when viewed from the moon, as it is when viewed from cislunar space, the space between the Earth and the moon. The Earth is the only visible object other than the sun that can be seen, although there have been some reports of seeing planets. I myself did not see planets from the surface, but I suspect they might be visible. The Earth is quite beautiful from space and from the moon. It looks quite small and quite remote, but it's very blue and covered with white lace of the clouds, and the continents are clearly seen, although they have very little color from that distance.
What about the sun? Could you see any trace of the corona?
No, the glare from the sun on the helmet visor was too difficult to pick out the corona. The only time we could see the corona was during an eclipse of the sun from the moon. That is, when we were flying through the moon's shadow and could observe the solar corona peeking out from behind the moon.
Looking at the photographs that you brought back, the coloured photographs of the moon's surface, it seems that the colour of the surface actually varies according to the angle from which you see it. Is this so? Does it do this?
Yes, it certainly does. It's a characteristic that we observe first while traveling around the moon in orbit. You can see that at the terminator, at the boundary between the black part of the moon and the lighted part of the moon, it was as if you were looking at a television set with the contrast turned to full contrast, very black and very white. As you moved further into the light, there were more and more shades of gray. But as you moved further, such the sun was higher above the horizon, you actually start to see the tans and browns appear, although at a very low level. Similarly, on the surface of the moon, the same characteristic is evident.
Now, why is it that we think that the known universe is larger than we can observe?
Well, one point is that it's expanding, and we always see the same radiation out there, so the glow of the Big Bang. But there are some deeper reasons. That one, from the theory of inflation, the best way to explain the universe, the properties that we see, is that it's very much bigger than the piece we can see. So, for example, we measure space to be what's called flat. I don't even have to say what's called flat. It is flat. So if you imagine slices of space, let's imagine slices of them at different times. So you just slice the universe and say there's a big sheet. It's like this table.
Okay, like a table.
There's a sheet of space, and there's another sheet, another sheet. And it can have a geometry, right? It can be flat like a tabletop, or it could be curved like a sphere, or it could be curved in the opposite direction, sort of like a saddle or a bowl. And we can measure that. And when we measure it, we see it's absolutely flat. And that's a very unusual thing for it to be like. It requires, because what Einstein's theory says is that the shape of space, that the curvature of space is determined by the stuff that's in it. That's basically Einstein's theory of general relativity. Put stuff in space and it curves it and bends it and warps it and stretches it and so on. And what we find is that there's precisely the right amount of stuff in the universe to have a completely flat universe. And the explanation, the most favoured explanation for that, is the universe is way bigger than the piece we can see. And so it's like looking at a piece of the Earth. If you look at a little 1 mile square of the Earth, right, then it's flat. Right? You have to look at big distances, kind of of order the radius of the Earth, or, bigger than 1 kilometre anyway, or 1 mile, to see that actually you're on a curved surface. And that's one of the ideas about the universe and why it appears to be the way that it is, because it's way, way bigger.
People who've been in the rocketry business for decades,
Yeah.
who say about you that you don't know what you don't know.
Well, I suppose that's true of anyone. How can anyone know what they don't know? But
When critics say you can't do this, your answer to them is,
we've done it.
you know, there are American heroes who don't like this idea. Neil Armstrong, Gene Cernan have both testified against commercial spaceflight and the way that you're developing it, and I wonder what you think of that.
I was very sad to see that, because those guys are, yeah. You know, those guys are heroes of mine, so it's really tough. You know, I wish they would come and visit and see the hardware that we're doing here. And I think that would change their mind.
They inspired you to do this, didn't they?
Yes.
And to see them casting stones in your direction.
It's difficult.
Did you expect them to cheer you on?
So they're hoping they would.
What are you trying to prove to them?
What I'm trying to do is to make a significant difference in spaceflight and help make spaceflight accessible to almost anyone. And I would hope for as much support in that direction as we can.
Although certainly there's the problem of the environment, the vacuum, and the high and low temperatures of day and night, still in all, in many ways, it's more hospitable than Antarctica might be. There are no storms, no snow, no high winds, no unpredictable weather phenomena that we're yet aware of, and the gravity is a very pleasant kind of place to work in, better than here on Earth. And I think it would be quite a pleasant place to do scientific work, and quite practical.
Mr. Armstrong, thank you very much. And again, let me say what a tremendous honor and privilege it's been to have you with us.
Thank you.